So today we're going to solve some matrix systems. We're going to take a system of equations and put them in a matrix form and then solve. We're going to do it two ways, using inverse and your new best friend, RREF. So you can see here we have a system of equations. What you want to first do is make sure that they are in this order, that you want to make sure first all of them are in the same order, whatever variables you're picking, x, then y, that the rest of the equations follow in the same order, that the x's will line up, the y's will line up, and it will equal the constant on the right side. So then you're going to come over here, you're going to take, because I have two different variables, I'm going to make a 2 by 2 matrix right here. That's of all the coefficients. And then you'll have a 2 by 1 matrix of x and y, and that'll equal your constants, okay? Sure that it's in this setup. So then we're going to solve by taking the inverse of both sides, okay? So let's go do that with one of them. So I start here with example number 1. I'm going to set up a 2 by 2, and it's going to be 2, 3, 1, 2. There's my 2 by 2 matrix. Then I'm going to have a matrix of x, y, and a matrix of 11 and 6. I'm going to take this one really slowly, showing you all the steps. So first thing we need to do is find the inverse. To find the inverse, I must first find the determinant. So let's start with that. So the determinant is going to be 2 times 2 minus 3 times 1. And sometimes it's just a good day and you get a determinant of 1. So we're going to say 1 over 1 to create the inverse. Next thing I'm going to do is switch the a and d spot. Look, they're both still 2. And then I negate the b and the c. So I have -1, -3, multiply through by 1. Look at that. I've got an inverse of 2, -1, -3, and 2. So now I want to take that matrix and I want to multiply. Now here's the tricky part. A 2 by 2 can get multiplied by a 2 by 2. But remember that matrix multiplication is not commutative. So the order where I'm multiplying these 2 by 2s, my red right here and the green, is going to matter because it's going to matter what order I multiply the matrix of the 11, 6. That is a 2 by 1. So that has to go second. Let me show you that. 2, -1, -3, 2, and then the 11, 6. So here's the 2 by 2, and this is 2 by 1. These two, you remember, have to match. I could not do it in the other order. It would not multiply. So with the same ruling, I have to multiply this side, the left side, by the inverse first, times the original. Let me put that in green so it's less confusing. And then here's my xy right there. Okay, I'll put that so you know that's original as well. All right, so now I've got the setup here. We're going to go through and solve. So starting, if you want to shift them up, feel free. Okay, I'm going to do top row, first column. So 2 times 2 minus 3 times 1, 4, minus 3, we'll just clear that. 4 minus 3 is 1. So that's a good start to creating the identity matrix, right? So then I'm going to go top row, second column. So 2 times 3 minus 3 times 2, 6 minus 6, 0. Excellent. Okay, bottom row, first column. So -1 times -1 times that 2 right there, plus 2 times 1. Look at that, 0. It's just excellent around here. And the last one, -1 times 3, plus 2 times 2. Voila. Okay, identity matrix, that's super awesome land right there. So then we're going to come over here. Remember, this was where order mattered. So top row is going to be the 2 times negative 3 times the first column and the only column. So that's always nice. So I have 2 times 11 minus 3 times 6. So 22 minus 18, that's going to be 4. And then the second part, negative 1 times 11 plus 2 times 6 is going to be negative 11 plus 12, 1. Perfect. And then the finale, being able to multiply across, I can see that this one would be 1 times x and then 0 times y. So x equals 4. Y equals 1. All right, let's practice this skill again. So first step, you can see the A's and the B's and the constants are all where they should be. So go ahead. 5, 3, 3, 2 is my 2 by 2 matrix. X, Y, and then 7 and 5. Next step, find the inverse. First step of that is finding the determinant. So here we go. We're going to say 5 times 2 minus 3 times 3, 10 minus 9. Another determinant of 1. That's always nice. Nice little gift for us. So we do 1 over 1. Switch the 5 and the 2. Negate the 2 3s. And I love multiplying by 1. Life is good. So let's set up order here. This should say inverse. We're going to multiply by the inverse first. Again, it may look like it doesn't matter on this side, but it does because everything matters. 1, multiplication in matrix is not commutative. Keep that in mind all the time. And then over here, we have to put the inverse first because a 2 by 2 can then multiply by a 2 by 1, but you could not go in the other order. So here we go. Hold on. One more marker. Okay. So again, when I multiply an original matrix by its inverse, I'm going to come out with, oops, forgot to have my XY there. I'm going to come out with the identity matrix, which is awesome. And then when I multiply over here, 2 times 7, 14, plus negative 3 times 5, I'm going to end up with negative 1 in the top there. And then in the bottom, I'm going to say negative 3 times 7, negative 21, plus 25, and we're going to get 4. So in this case, x is negative 1, y is 4. We're going to head on to the next one here, number 3. So go ahead, you try that one. Number 3, you should have gotten x equals negative 2 and y equals 8. So now we're going to step up to the big boys here. We can see we've got 3 variables, which means we need a bigger matrix. So we're going to make a 3 by 3 here. 2, 5, 1, 1, 1, negative 1, 3, negative 2, negative 9. Then a 3 by 1 of x, y, z, and then a lovely 3 by 1 of 1, 8, 5. So the first step is to find the inverse. Now, it is technically possible to do by hand. We have only learned to find the determinant. So you're going to use the calculator, as we've taught you already, and the inverse, let's get a new color marker here, of this 3 by 3, just type that in, is going to be 2, 5, 1, 1, 1, negative 1, 8, negative 2, negative 9, And you're going to multiply that by the original matrix here. 2, 5, 1, 1, 1, negative 1, 3, negative 2, negative 9. I need to slide things. 1 second. Okay. All right. Again, putting the inverse first. 2, 5, 1, 1, 1, negative 1, 8, negative 2, negative 9, times the 1, 8, 5. So over here, I get the identity. And on this side, I'm going to end up with 4, negative 10, and 1. So that means, I need more space, it means x equals 4, y equals negative 10, and z equals 1. Go ahead, try this one. You want to make sure that you're lining up the spots here, that this should have a plus 0 z in there for its constant, okay? So here are the answers to 5 and 6. Hopefully yours were the same ones. We're now going to take a look at RREF. You'll notice the first difference is that we're going to put the whole matrix, the whole system, into one matrix. Again, make sure that everything's lining up x and y's. Make sure that the variables are on the left and the constants are on the right. And it'll create this gorgeous matrix right there. So then, once we've done this, you're going to come up here on your calculator. You're going to go to Menu. Oh, we have to get in here. Sorry. So, Menu. We're going to do some matrix mathematics. You're going to go to number 7. And we are looking at number 5, reduced row echelon form. Okay, and then we need to create a matrix. So I'm just hitting that lovely little button right there. Come down to the 3 by 3 looking one. And in this one right here, I have 2 rows and 3 columns. I asked that to create that, and I'm going to fill it in. 1, I use the tab button. 3, 5 to work my way across. 1, 4, and 6. And voila, it creates that gorgeousness. Oh no, it went away. Hold on. Go. So we have 1, 0, 2, and 0, 1, 1. You can see right in here, there's the identity matrix, okay? So we know the top row is our x, so x is 2, and y is 1. You're now going to try that. Use the same setup for these 2, and you'll have typed them in, so it should work just fine. Lastly, here's one more to try. All right, remember these gorgeous quadratics that take forever to solve? Yeah, there's an easier way. Here we go. We know the formula is y equals ax squared plus bx plus c. And when I write these, I can do just that. That this first one right up here, I would have 64a plus 8b plus c equals 38.6. Then I'm going to have 9a plus 3b plus c equals 26.6. And again, I've just moved the y to the other side because I need my constants to be over there. And then we're going to do 14 squared, 196a plus 14b plus c equals 13.4. So then I come over here, Menu 7, reduced row echelon form. I'm going to create a matrix, and I'm going to need 1, 2, 3 rows, 4 columns, and then just fill it in. 64 8.